Hey everyone, the day is finally here. Llama 3 is live. So there's a little bit of background. Meta had completely changed the game when they open sourced Llama 2, showing that we can have a super capable large language model with open sourced weights. And shortly after they had announced Llama 2, Meta had kind of put it out there that they were going to be working on Llama 3 that was going to be even more capable and feature a larger model. And we'll see later on in this blog post that they're working on a 400 billion parameter large language model with the intention to open source it. So that's maybe the most interesting aspect of this, is that they're open sourcing the model. This allows the opportunity for all sorts of third-party inference API providers. In this video, we'll look at a demo with Ollama. We can also say serve the model with Together AI, AnyScale, Grok. So there's this interesting opportunity around serving these models. And then, of course, we have the open source, we have the weights, so we can fine tune these models with gradients and use things like Hugging Face and generally, control the model. So there are just so many interesting things to this. The AI world has kind of collectively been holding our breath for this announcement of Llama 3. So I'm so excited that, here we are today and the announcement has been made. So in this video, we're going to first dive into the blog post, how Meta is presenting their new large language model. And then in the second half, we'll look at some demos, how to build a retrieval augmented generation system with it, as well as this super exciting new idea of using DSPy to find the optimal prompt for this particular large language model. So I'm so excited to dive in. Let's see what Meta is telling us. All right, let's cover everything in the release blog, introducing Meta Llama 3, the most capable, openly available large language model to date. So they begin by telling you, how you can use it, Amazon, Databricks, Google Cloud, Hugging Face. So quickly, I'd say that this is also an Ollama now, and thank you so much to the Ollama team for getting this done, and then, updating with the new chat and how you had to respond with that to take out the assistance thing. And so all that, just being able to go to the Ollama Discord and, watch everyone hacking on it and saying, hey, is it ready yet? When do I update? It's been a super cool, experience. And through Ollama, you can use it in Weaviate as well as DSPy, which we'll see later in this video. Okay, so next up is, in addition to announcing the model, they're giving some tools to help with, guardrails and safety tools, Llama Guard 2, Code Shield, cybersecurity eval 2. So I'm not super familiar with that personally, but some things that they're releasing around the model as well. So in addition to the model, they're also teasing that in the coming months, we expect to introduce new capabilities. So by new capabilities, they, what does that mean? They clarify that later in the article, or by that they mean improved reasoning ability and improved coding ability. So when you're talking about features in large language model, the capabilities, sort of like the analog from software, is that you think about the training data is how you program the features of the large language model. So when they say this new capabilities, what they mean is that they probably have this, they're curating a new data set of, specialized for reasoning and coding tasks. And so they're going to keep training their model on that. Maybe, it has a larger composition of the data set as they go forward, and that's how they'll introduce new capabilities. So then longer context windows. So Llama 3 is going to have an 8,000 input window, which is a bit shorter. Say the last video was about Cohere's Command R+, which has 128,000. So that's kind of maybe one thing to take note of as you're switching or thinking about switching your models around to integrate Llama 3 with what you're working on. So then they're also proposing additional model sizes. At the end of the blog post, we'll see that they're working on a 400 billion parameter open source large language model. So that's a pretty amazing update from just, following along with this for a while. Okay, so, and then they're also saying that the research paper is coming out soon. Okay, so the next up, a pretty major thing is that we have another one of these chatbots systems that come with a new model. So we saw Mistral recently had unveiled LeChat alongside their model. Obviously, we have ChatGPT and then say Anthropic Cloud. So we also now have Meta AI. Maybe uniquely is how you log in with Facebook and how it's like linking this massive social media platform with the the chatbot and all that kind of stuff. So interesting development. I personally, obviously, as we'll see this DSPy demo, I'm really more fascinated with the systems and the things you build around large language models by connecting them in these pipelines, agents, if you prefer that. So I always really like seeing these kind of systems as well as just the model itself. Okay, so next up, so they're releasing the first two models, so 8 billion parameter and 70 billion parameter models. It's super, super important to note that the pre-trained model and an instruction tune model are two separate things. So if you're going to be fine-tuning with, say, you have your own data set for preferences and you're going to RLHF it and all that kind of stuff, then you go for the pre-trained model. But if you're going to be plugging this into your applications and, say, prompt optimizing it using few-shot examples, then I highly recommend using the instruction tune model. So pre-trained model has just been language modeling the internet, or maybe it's also been language modeling a downstream kind of more curated data set. But the instruction tuned models, they've been doing, RLHF, or say like, with this like DPO, PPO, all that kind of stuff on preferences. So they're going to be better at following instructions. Okay, so next up, our goals for Llama 3. So something that stood out to me in this is that they're starting off with the text-based models. Our goal in the near future is to make Llama 3 multilingual and multimodal. Later on, I think they say something like 5%. We'll just see it when we come to it. But so, adding multilingual, multimodal, longer context, and then again, improve the capabilities. By that, they mean reasoning and coding skills. Okay, so probably my favorite thing about seeing these new large language model announcements is the state-of-the-art performance. What's the state of how people are reporting this? Okay, so Meta is going to be using academic benchmarks. So we're looking at MMLU, GPQA, Human Eval, GSM 8K, and Math dataset. So let's take a look at the dataset. So here is the MMLU benchmark. This is probably the most used measuring stick for large language models. So I'm going to skip ahead to the end of the section where they have an appendix that kind of explains it a bit. So what the MMLU benchmark is it's designed for massive diversity for evaluating large language models. So you have tasks like abstract algebra, anatomy, or marketing, or nutrition. So it covers an insane diversity, and it's a summary of all 57 tasks included in this data set. And so here are some examples of what these data sets look like. It could be, it's a lot of multiple choice. So you have a question like, what is the, I'm not going to read these, but you can see examples of this data set. So this is the first thing they're reporting is this one, measuring massive multitask language understanding. And then say another one that's very interesting to me is human eval. So this is evaluating large language models trained on code that unveils this data set. And so it's got questions like this where you have like kind of coding problems, like what you see in say LeetCode code and things like that. And then it's able to write the code that passes the test. So another pretty interesting way of measuring these models. So they're comparing it to, Llama from Google, Mistral 7B Instruct, and then they also have the 70 billion parameter model, which is compared against Gemini Pro 1.5 and then Cloud 3 Sonnet. So these results are probably the thing that will catch your eye the most. The fact that this open source model is on par with Gemini Pro 1.5 on these data sets that kind of everyone is using as the measuring stick generally. So maybe one other thing you'd be interested in knowing is that 5-shot means that there are 5 examples of the task used in the input, whereas 0-shot means instructions only. And then chain of thought means that you also add let's think step by step to the prompt, and then 8-shot chain of thought means that the examples also have chain of thought reasonings in them. Okay, so next up, they published a new data set. So the new data set consists of 1,800 prompts for 12 use cases, asking for advice, brainstorming, blah, blah. So another data set for the sake of comparing these models. Okay, so next up, this is my favorite way of evaluating large language models. Instead of kind of just having a benchmark where there's all sorts of concerns around have you trained on the test set, they even have a part in the blog post where they say our modeling team was never allowed, or with this data set they just say, they say something like, to prevent accidental overfitting of our models, even our own modeling teams do not have access to it. So, it's buried underground, no one can see it and all that kind of stuff. But here I think is a better way of evaluating these models, which is where you have the response from 2 models and you either have a human that says, which one is better, or you say another large language model would be capable of doing this, and you have win rate, and that kind of thing. So we've got Meta Llama 3, 70 billion instructed versus Cloud Sonnet, achieving 53% win rate versus Mistral Medium, GPT 3.5, and then Llama 2. So I personally really like this way of evaluating large language models. Okay, so next up we see more of the pre-trained model performance. So maybe coming back to what I was talking about earlier, if you see this difference between the 8 billion pre-trained only, it has 66.6. Compared to above with the instruction fine-tuning, we have 68.4, so not a super massive difference, but maybe let's look at the 0-shot. So 0-shot human eval is 62.2. So it's not the same data sets, it's AGI eval. Okay, so anyway, so hopefully you get this idea of, pre-trained. The reason that the pre-train is so powerful is because, if you're going to be fine-tuning this model, it's a better starting point compared to the already instruction-tuned version of it. And that's kind of what I think the common, consensus is around thinking about pre-trained and instruction-tuned models. Then we have some details about the model architecture. So we have the detail of how many tokens are in the tokenizer in the vocabulary, so 128,000. And it was super interesting in the last video covering Cohere's Command R+, to understand how their tokenizer has this kind of multilingual support, and the result of how that you need less tokens to encode different text. So I think the multilingual thing is maybe the most interesting story around tokenizers, at least what I'm currently aware of. So next up, you have a detail in the architecture. So I think last year there was a bit of like flash attention. Everyone was like, they're innovating on attention, and that's going to result in these totally new models. I'd say now it's mostly a mixture of experts and a bit rising in state space models, but we have this announcement, grouped query attention, GQA, and they describe how this is the reasoning for 8 billion parameters. So, there's this kind of like dark magic thing of Tim Detmers had published this thing about quantization, which I think it was 6.7 billion is like the magic number where a model has to be larger than that to be capable of reasoning. And, Llama 2 was 7 billion, and then Mistral was 7 billion. So it was kind of like, okay, is 7 going to be the number? But so they're explaining how this grouped query attention is like why it's 8 billion. Okay, so next up is the training data, and this is a pretty interesting, and then scaling laws and all this kind of stuff. So starting off, it's pre-trained on 15 trillion tokens, so it's an absolutely enormous data set, 7 times larger than what they use to train Llama 2. And then so here's the nugget about multilingual. So again, programming features into large language models is about having the training data for it to learn that kind of thing. So for multilingual use cases, over 5% of the Llama 3 pre-training data set consists of high-quality non-English data that covers over 30 languages. So, beginning to build that part of the corpus, the 5%, 30 languages, and that's how by increasing that number, that's how they would have more support, or as well as increasing the K in the number of languages and all that kind of stuff. So they also describe how they do some things like heuristic filters, not safe for work filters, semantic deduplication. There's so many niche categories for specialized skill sets, but this is definitely one of them. I've seen a lot of cool things from Nomic AI on how they use their embedding visualization to achieve that semantic deduplication, but there's definitely a lot into how they curate these pre-training data sets. Okay, so next up is scaling up pre-training, and scaling laws is maybe the most interesting topic in AI, because it's like if you can just keep scaling it and it gets smarter magically, because there's already this kind of like predicting the next token, and it forms this like magical world model as a result of doing so. And so there is a consensus around, well, what happens if we just keep scaling it up? And that's like the bitter lesson from Richard Sutton. It's just saying like, algorithmic innovation gets us somewhere, but scaling up the models, that is maybe our most effective lever. So the chinchilla optimal compute, this is a paper that came out from DeepMind. I'm not super familiar with all this, but they compute, they have plots of compute tokens and then the performance, and so they're extrapolating what would we expect based on, say, we did this run with 50 million tokens, and now it's here at 500 million tokens, and so on. So they have these plots for how they predict, because they're not just going to spend millions of dollars on training one of these models. They're going to try to forecast what will be the result of the additional compute, and that hopefully gives you a background of like what they're talking about here with this kind of scaling laws, and how they try to fit these coefficients on model performance as a function of model size as well as training steps, and perhaps the size of the data set as well. So I'm not sure if they do multiple rounds through. So, epochs makes a ton of sense when you have your cat versus dog classifiers, because you're going through the same data set and you have 1,000 cats and dogs. So you're going through that multiple times, but I'm not sure if they go through that 15 trillion tokens multiple times. But anyway, so I'm not really super caught up on that anymore, but hopefully that gives you a bit of background if helpful. Okay, so then they describe this, 2 custom-built 24,000 GPU clusters. So the computational resources here is just crazy. All right, so combined, these improvements increase the efficiency of Llama 3 training by 3 times. So they're describing how these things like that, grouped query attention and this new data center and all this kind of stuff, how they're getting more efficient, they're getting better at pre-training these models. And of course we saw, say, Mosaic ML, and they made tons of breakthroughs in pre-training models, and so that's what they're saying. Okay, so then instruction fine-tuning, this is a topic I wish I knew more about, and I can't wait to dive into it further, especially with DSPy's Bootstrap fine-tune teleprompter compiler. But so they're describing basically how, their thoughts on supervised fine-tuning, rejection sampling, PPO and DPO, and how we get these instruction tuned models. And there'll probably be more details to this when that research paper comes out. Okay, so then they have some things around the guardrails, things like, say, harmful output detection, as well as this kind of structured output decoding. I'm a huge fan of, say, instructor, as well as SGLang and DSPy's type predictors and assertions. So there's a lot of things now around enforcing structured outputs. And then also, of course, like checking for harmful content and so on. And another one that's really good in that kind of thinking is Harrison Chase describes this as a state machine, because Harrison, LangChain, they've done a ton of work on these like language model graphs where you have like 8 calls to language models, and he describes really nicely how you're trying to avoid like some kind of crazy state transition and how the language model transforms the text at any kind of step in that processing. So maybe another useful way of thinking about this. Okay, so we've also co-developed Llama 3 with TorchTune, the new PyTorch native library for easily authoring, fine-tuning, and experimenting with LLMs. So I think this is pretty fascinating. We saw, I think, AutoTrain from Abhishek at Hugging Face. That was maybe, in my understanding at least, one of the most successful efforts on this kind of automated fine-tuning library. But it looks like we have another one from PyTorch with integrations with Hugging Face, Weights and Biases, and Eleuther AI. So I think this is another library for facilitating fine-tuning models with gradient descent using PyTorch. Okay, and then so a little more discussion of the system and how they intend for you to put these kind of guardrails around the input as well as the output. And of course with DSPy we think a lot about these kind of pipelines, and this is mostly the thinking. And then okay, so more of that, then intentions to deploy, more hat tipping to the grouped query attention, and how that maintains the inference efficiency with the Llama 2 7 billion, even though you have the 1 more billion, and so on. So then we have Llama recipes, probably a cookbook of things you can do with Llama 3. And then here's the big thing. What's next for Llama 3? Okay, so this is the announcement. This is it's all great, but here's probably the craziest one. Our largest models are over 400 billion parameters. So back when GPT-3 was like 175 billion parameters, I don't think anyone had even fathomed the idea, and it cost millions of dollars to train. I don't think anyone had predicted that this scale of models was going to be open source. And so it's pretty remarkable to see 400 billion parameter plus model open source. So Meta Llama 3, so they're saying it's still training, and like here's where it's at now. So it's pretty interesting with the scaling laws thing. So that they're still training it, and they expect to have it get better as they continue training. Okay, so try Llama 3 today. Let's dive into a demo with DSPy. All right, let's dive into a demo showing you how you can use Llama 3 with Ollama and connect it to DSPy and Weaviate. So first up, a quick overview. So again, you can see the release notes that we just looked at, and just huge thank you to Ollama for supporting this model. It was really funny seeing when they first put this live and you saw like 1,000 polls in like 2 minutes. And just so this is how you can get it. You go in your command line, install Ollama, and then just Ollama run Llama 3. And you can put these tags on it. So maybe see where I'm typing here. You just have like Ollama run Llama 3, and then you put this tag on the image. So if you want the instruct model, you just do it like this, or or the 8B. So you see they have this 8B, but this is the one that you want to use probably, is these quantized 8. I'm not exactly sure why, but I just from seeing the Discord and from talking to some people and trying it myself, that you probably want to use this model. This is what we'll be using in a second. So the way you do that, if you see me typing up here, would be Ollama run Llama 3. Oh, well, you see it right here, actually. So you just run this in your terminal. Okay, anyway, so thank you so much to Ollama. All right, so next up, so we're going to start by looking at how to build a RAG system with Llama 3, Ollama, Weaviate, and DSPy, and then we're going to use DSPy's MIPRO optimizer to find the optimal RAG prompt for using Llama 3. This is one of my favorite stories, is this kind of idea of the same prompt isn't optimal for all these large language models. And so I'm so excited to be making some more steps into comprehensively exploring that when new language models come out with this notebook. So anyway, so first thing you do is you connect to dspy.ollama local, and we pass in the model. So I'm using 8b instruct and then q5_1. I'm not sure what the difference is between q0 to q8, but this is the instruction tuned model, and then it's probably been quantized so that you're able to run it on your laptop this quickly. Okay, so then we connect to Weaviate, and then we set the defaults in our DSPy to be use LLM and our retrieval model. So first thing I like to always just check that it's connected by just passing in the LLM, say hello. Okay, so there are 4 key steps to using DSPy's compilers, and so I'm kind of entangling the setup of the compilers with just a basic RAG demo. But the first thing you would need is a data set. So I have this Weaviate blog rag. This is in this Weaviate recipes folder. And this just has questions and answers synthesized from the Weaviate blog data set. So I separate these into train, development, and test sets so that I can optimize with the training set, tuning hyperparameters by monitoring the development set. And then when I'm finished with my optimization, I evaluate on the held out test set. Okay. So next thing, you have a metric. So this is a pretty, hand wavy metric, and I'm planning to do the next video in the DSPy series, maybe as a teaser, will be about diving into these LLM metrics. But for now, we just have evaluate the quality of a system's answer to a question according to a given criterion. And you pass in the criterion, the question, ground truth answer, and so on. So we're basically just saying how aligned is the predicted answer with the ground truth, and it outputs a rating on a scale of 1 to 5 of how aligned it is with the ground truth. Okay, so then our DSPy RAG program generate the answer. We have our initial prompt, assess the context and answer the question, our two input fields, the context and the question, and then our output field, an answer, a detailed answer that is supported by the context. So then we build our RAG program where we start our modules. We have our retrieval engine, and then we have our generate answer prompt. And then in the forward pass, we take the question and we use it to retrieve the context. And then we pass in the context and the question to our generate answer prompt, and we get the answer, and then we return the answer. So this is the idea of DSPy. One idea of building these complex systems is you can have several different prompts where the output of one call is the input to the next call, and you can integrate tools like retrieval or calculators or Python interpreters and all this kind of stuff. So once you have this program, you can just create it and then run it with a question like, what is binary quantization? And this is retrieving from a Weaviate index filled with index chunks of the Weaviate blog post, so it can retrieve some information about binary quantization to answer this question about what it is. Okay, so next up, compiling with MIPRO. So MIPRO, we've recently published a blog post on Weaviate.io, which is about covering Bootstrap Few-Shot with random search or Optuna, CoPro, and MIPRO. So MIPRO is the heavyweight of the DSPy optimizers, and it's doing 4 things. So the first thing it's doing is it's looking at your training set to make observations about it, to summarize what's in your training set. And then it's taking that information to propose paraphrasings of your task. And now for each paraphrasing of your task, you're now going to use Bootstrap Few-Shot, where you're going to be bootstrapping an example with that particular instruction. So say you had assess the context and answer the question, and then you write a paraphrasing, which is like, please carefully read these documents. Now you're going to bootstrap an example with the please carefully read these documents thing, as well as so you had another paraphrasing that was like, carefully review all the context, form a coherent response, blah, blah, blah. And so you would also bootstrap for that other prompt. And so you get more insight into how effective each of the paraphrase instructions are by also pairing them with examples. And then MIPRO will do that same kind of thing that CoPro does, where it's observing like how these different prompts are performing and using that to again propose another paraphrasing of what would be optimal prompt. So in this case, using this data set, we start off with assess the context and answer the question. And we end up with, given the provided context, your task is to understand the content and accurately answer the question based on the information available in the context. You should use formal English with technical terminologies where necessary and provide a detailed, relevant response. So this prompt ends up performing better than this one when using it for RAG. So this is a huge concept. I think that, for me, I wasn't quick to understand this. So, I try to slow it down and help other people understand it. But like when you're prompting an LLM, the details of the language for how you're going to communicate this task, it matters tremendously. So this is how you use it with MIPRO. And so it's going to be searching through all these prompts. And then in the end, you just, have this new optimized prompt, what are cross encoders. And you can see how when you inspect the history, this is the call to the language model. You plug in the optimized prompt, and then you follow the format where you give the input and output fields, and then you have the context, and then you have the answer. Thank you so much for watching this video on the long-awaited release of Meta's Llama 3. Thank you so much to the Ollama team for supporting this so quickly, and of course, thank you to the Meta researchers who've created this model and open sourced it. It's all just so exciting for the state of AI, whether we're running it locally or reproducing results for the sake of science, and generally feeling like we own these models, so to say, when you have the weights and all that. So it's just such an exciting development, and all of this is just really interesting to be keeping up with. Really quickly before ending the video, we're hosting a meetup with Arise AI and Cohere featuring Omar Khattab, the lead author of DSPy, in San Francisco on Wednesday, May 1st. It's going to be so much fun. I'm so excited for it, and I really hope to see you there. This event page will be linked in the description of this video, as well as, of course, the Weaviate recipes repository, where all the notebooks for this DSPy series can be found. Thank you so much for watching.
you.